Hello friends, today I am now going to discuss in very brief that how we can determine the polarization state. That means in our previous video we have discussed the introduction to the polarization. Now a polarization state of an electric field, that means how they are polarized, that means if they are linearly polarized or they are circularly polarized, linearly or plane polarized, or they are circularly polarized, or they are elliptically polarized. How can we determine? Today we will discuss very short about that. So let's start. First of all, you have to know what? First of all, you have to know the representation of electric field. Representation of electric field in its complex form. How can we determine the electric field in complex form? So in complex form, electric field can be written as E vector equals E0 exponential iota k dot r minus omega t n cap. This is the representation of electric field in a complex form. So here E0 is what? E0 is the amplitude of the electric field. K is what? K is the propagation vector. Propagation vector of the electric field. Omega is what? Omega is the frequency of electric field. R vector. R vector is the direction of propagation vector of the electric field. And N cap is the direction of electric field. Remember this. R vector is what? R vector is K dot R cap. Here it will be R cap. K dot R cap. R cap is the direction of propagation vector of electric field. And N cap is direction of only electric field. So let us consider two electric field is there. E1 equals E01 exponential iota kz minus omega t into x cap. Here another electric field is such that E2 equals E02 exponential iota kz minus omega t plus phi y cap. There are two electric field. If they are superposed, then the superposed electric field, what will be the polarization state? Now we will discuss. If they are superposed, E1 plus E2, now how we can determine the polarization state? So there is some tricks or there is some formula from where we can easily determine their polarization state. So how can we determine? If E equals E01 plus E02 such that if rule 1, if amplitude of the first electric field or amplitude of the second electric field equals 0, then it will be plane polarized. That means if amplitude of the first electric field or amplitude of the second electric field equals 0, then it will be plane polarized. Now second rule is that if E1 vector and E2 vector are in same direction, that means it has also in x cap, it has also in x cap, are in same direction, then what we can tell? Then we can tell it plane polarized. Another rule is that this is for plane polarized. Now another rule, if both are different plane, that means E1 vector and E2 vector, this is such as xy plane, this is yz plane, both are in different plane, means E1 vector and E2 vector, let me write clearly, E1 vector and E2 vector different plane, different plane, then what are the following case? If amplitude of the first vector or if the amplitude of the second electric field vector 0, then it will be plane polarized. Same thing. It is for the rules for different plane. And if phi, that phase factor, equals 0 or n pi, then also it will be plane polarized. Then also it will be plane polarized. If for different plane, another rule, if E1 and E2 are different plane, but in that case phi equals n pi by 2 and n is odd, and E01 and E02 amplitude of the both electric field vector are same. That means E01 equals E02. Then we can say circularly polarized. Circularly polarized means two vectors are there. E1, E vector equals E1 plus E2. It has amplitude E01. It has amplitude E02. Now E01 equals E02. Both have same amplitude. Then we can say that it is circularly polarized. Circularly polarized. Now there is another condition for another rule for circularly polarized that we know. Let me clear. Circularly polarized. One is left circularly polarized, another is right circularly polarized. How can we determine that one electric field is left circularly polarized and another superposed electric field is right circularly polarized? There is another rule that if for phi equals n pi by 2, we know phi equals n pi by 2 and n is odd, then also it is circularly polarized. Now the left-handed circularly polarized and right-handed circularly polarized depends upon n value. If n value is such that n equals 4m minus 1, then it will be left-handed circularly polarized. 4m minus 1 means for m equals 1, what you will get the phi value? Phi equals 3 pi by 2, 7 pi by 2, etc. And if n equals 4m plus 1 pi by 2, then you will get phi equals pi by 2 and for m equals 0 value. For m equals 1 value, phi equals 5 pi by 2, 9 pi by 2. Then it will be right circularly polarized. Another rule is rule D. If the amplitude of the both electric field are not same, then it will be elliptically polarized. Elliptically polarized. Another rule for elliptically polarized is that rule number E, you can say, if phi not equals 0, pi by 2, pi, 3 pi by 2, 2 pi, etc. That means if phi equals pi by 4, 5 pi by 4, then it will be also elliptically polarized, even the amplitudes are same. But phi not equals these values and phi equals pi by 4, 3 pi by 4, then it will be also elliptically polarized light. Another rule is that, and the most important thing is, if frequency of both polarization means of both electric field, frequency of both electric field, that E01 frequency omega 1 and E02 frequency omega 2, both are not same. If both are not same, then no polarization. So these are, in very short, I have described you that how we can determine the polarization state. So let us take an example so that you will be cleared. So let us consider superposition of electric field vector to electric field vector, such as E vector equals E0 x cap plus e to the power pi by 4 y cap exponential I kz minus omega t. Now in that case, what you have to do here, you know these things. I have told you the complex representation. You know this value also. Now notice one thing here, E0 for both case. Here the direction of first electric field is x cap, second electric field direction is y cap, and the propagation vector of both electric field is z cap. But though it has same value of amplitude, it has phi equals iota pi by 4, that is pi by 4. That means it is elliptically polarized light. Similarly, I am taking another example. If E vector equals E0 x cap minus y cap, then and e to the power I kz minus omega t. Now you can write here as such a way. So you can write here in such a way, E0 x cap plus exponential I pi y cap. So here phi is what? Phi is pi. That means n pi. N equals 1 here. So that means this plane polarized. So in that way, you can take more example and you can determine how the polarization state is there. That means it is either plane polarized, linearly polarized, circularly polarized. That's it. You can determine. So these are some rules how you can determine the polarization state. So that's it for today. Thank you for patiently watching. Bye.